In this video, we're going to talk about all of the angles created when two parallel lines are cut by a transversal. If you find this video helpful, please like and subscribe for more geometry content, as well as other math courses. So we have two parallel lines, okay? And of course, we should, put the symbols on there to say they're parallel. If you remember that those look like this. And they're cut by another non-parallel line. We call this a transversal. Okay, so parallel lines that have been intersected by a transversal. Now, we've already talked about vertical angles before. These are angles that are across the intersection from each other. Now, I'm not going to list all of them here, but let's just start like 1 and 4 are across from each other. So let's write that angle 1 and angle 4 are vertical. And, of course, another example there would be angles 2 and 3 are across from each other. And the relationship here between those is that those angles are equal to one another. Okay, they will have the same measurement. And obviously we've got two more pairs down here, 5 and 8 and 6 and 7. Now linear angles, these are angles that form a line. So for example, angle 1 and 2. You can see angles 1 and 2, that this makes up an entire line. Angle 1 and angle 3 are also linear angles, angle 1 and angle 3. Now, I should just put like a ... because I'm not going to list all of these because these are relationships we've already talked about. These aren't new. But 1 and 2 and 1 and 3 and 2 and 4 and 3 and 4, 5 and 6, 6 and 8, 8 and 7, and 5 and 7. Any two that make up a line, and of course the relationship here is that those two angles, when their measures are added together, add up to 180 degrees. Okay, so vertical angles are equal, and linear angles add up to 180. Now, let's do some new relationships. Corresponding angles. So how I would like to think about this is we have two intersections created. So let's say, this is like intersection number 1, and this group is intersection number 2. Corresponding angles are angles that are in the same location in these two intersection points. So for example, this, if you think about, this is 4 things. This is the upper left angle created. So we come down to the upper left, it's 5. So angles 1 and 5 are angle 5 are corresponding. And angle 2 and 6 are corresponding. And I could keep going. I'm going to put ... just for the, sake of room here, but 3 and 7, lower left, and 4 and 8, lower right. Now, the relationship there between corresponding angles is those are equal to one another. Okay, so the measures of angle 1 and angle 5 are the same. The measures of angle 2 and angle 6 are the same, 3 and 7 and 4 and 8. Now, alternate interior. Now, alternate, this kind of is the same as opposite. Interior means inside. So look at, first of all, the angles that are inside, meaning they lie inside the parallels. Okay. Now, alternate, of course, means opposite sides. So 5 and 4 lie on opposite sides. So angle 5 and angle 4. Okay. The other ones are angle 3 and angle 6. Okay. So again, just track that they are inside the parallels and on alternate sides. The relationship there, those angles are equal measure. Alternate exterior. So now exterior, this means outside. So 7 and 8 and 1 and 2 are outside the parallels. Alternate again means opposite. So 1 and 8 are on opposite sides of the transversal and they're exterior. So angle 1 and I'm going to put and angle 8 and 2 and 7. And the relationship there, those are equal. So on the alternate sides, those are equal. Now, let's go to same side. Interior. So interior means the same thing. We're dealing with these 4, 3, 4, 5, 6, the ones that are inside the parallels. And of course, same side means they're on the same side as the transversal. So we're going to be dealing with 3 and 5. So angle 3 and angle 5. And angles 4 and angle 6. And the relationship there, well, those angle measures will add up to 180. Now, I want you to be thinking ahead of why we might know that. Well, if we know that 3 and 4 add up to 180, and 3 and 6 are the same, well, then 4 and 6 must also add up to 180, right? The linear pair here, and we know that these two are the same, well, then we can also say that these two must also make up that linear pair, okay? Now, same side exterior. So now, of course, we're talking about 1 and 2 and 7 and 8 because those are outside, they're exterior angles. And same side, so 1 and 7. Angle 1 and angle 7. And the others would be angle 2 and angle 8. And same kind of reasoning here. These two measures will always add to 180. And we can kind of, again, use linear angles and say, well, if I know that these two add up to 180, because it's a linear pair, and I know 3 and 7 are equal because they're corresponding, then 1 and 7 must add up to 180. So you can kind of use some algebra logic here. So those are all of the types of angles we can create when we cut two parallel lines by a transversal across them. These are good things to know. Please, again, like and subscribe for more help on geometry.